Welcome to the Data Beats show. We also have a free newsletter, so do check it out on databeats.community. So today we've got Zander Matheson from Bytewax, who's here to help us understand stream processing. So here we go. Hey Zander, thanks for joining.
Yeah, I'm stoked to be here, and I always get pumped up from that the beats at the beginning there. So let's go.
Awesome. Thank you so much, Zander. First question for you. In simple terms, what is stream processing?
Yeah, so stream processing very generally is the ability to process over a bounded or unbounded stream of data. So you process one piece of data at a time, and generally it happens in real time or something like that.
Okay. And what are the prerequisites in terms of the data stack to set up stream processing?
Yeah, generally, you're going to have some sort of streaming system that will involve like something like Kafka or Red Panda or Pulsar. So you either have like a I don't know a message broker or some format like that, and then you'll have some processing system, and that's what allows you to process the data. So it consumes from those more durable systems and manipulates the data and sends it out somewhere else. And that's like the at the bare minimum, that's kind of what you need to process streaming data.
Cool, yeah. And Bytewax, which you're building, is an open source framework to build data apps using streaming data. Can you briefly explain what it does and how it works?
Yeah, sure. So yeah, Bytewax is a framework. It's open source and it's a stateful stream processor, and it allows you. What we say is that it allows you to easily build on top of streaming data. So you can think of it as a tool for building applications that are leveraging streaming data, whether that be something more advanced like an online machine learning algorithm for anomaly detection or something like that, or it could be something more simple where you're just transforming that data in real time. And so yeah, it's a framework, and it gives you kind of the pieces to connect to streams of data, to manipulate them, and then connect to downstream other data systems.
And can you explain the key differences between stateful and stateless stream processing?
Yeah, so stateful stream processing. So one of the hard things about processing streaming data is maintaining a picture of what's going on, so that you can do more advanced things with it. And so that's the stateful part. So you can think of like, let's say I want to know all the things that happened for a certain user or over amount of time an amount of time. That's when you bring in state, because you want to have a window of time and then aggregate about a user. So you have to maintain this information about the user over time. So stateless, with stateless stream processing, you cannot do things like that. It's basically sort of like you just are acting on one piece of data at a time, and it very very much simplifies the problem, because you don't need to know what else is going on, and you can scale it more easily.
Cool, yeah, that makes sense. And how can a tool like Bytewax be used in conjunction with an open source OLAP data store such as Apache Pino?
Yeah, so you can use various systems downstream of Bytewax. It really depends on ultimately how internally other people are going to interact with the data, or how you're going to serve it. So Bytewax could be used for a transformation layer before something like an OLAP database. If you're then, you have a bunch of dashboarding, reporting you're doing that's on top of that real time, uh, or on top of Pino or something like that. And so with Bytewax, you could do some transformations, some adjustments to the data, maybe add in third-party data sources, and then write it out to Pino, and then your system downstream of that does the have a query or something like that, some dashboards.
All right, cool. So switching gears now, what are the top two use cases of stream processing technologies?
I think probably the most common use cases today for stream processing are most likely based off anomaly detection. So there'll be applications of that methodology. So you have things like fraud detection for credit card transactions or something like that. or maybe anomaly detection could be used for in a cybersecurity use case. So detecting when there's some sort of anomalous behavior. Those are quite common use cases. I mean, I'm not sure what is the most common. There are many other use cases, but I think those are two that involve anomaly detection, which is a pretty good pretty good methodology that can be used in a streaming fashion.
And now, can you explain how stream processing can be used in e-commerce, and how can merchants use stream processing to build better shopping experiences?
Yeah, that's actually a really great use case for e-commerce, personalization of e-commerce sites. So, like Amazon, you use this for recommendations. Other e-commerce sites could leverage stream processing technology to personalize the shopping experience for each shopper that comes into the website.
And which industries benefit the most from stream processing tech? Are there industries where stream processing is non-negotiable?
So I think that to answer this question, it's best to zoom out. Stream processing is adds complexity to your infrastructure, and so it's important that there's an ROI associated with the change that you make. So if you're moving to stream processing or you want to leverage stream processing, you need to make sure that that increase in complexity is going to be worth it in the end. So industries where the closer you can get to real time to making decisions, or improving user experiences, those are like the best industries for real time. As far as like non-negotiable, there's plenty of instances in like IoT where it's a non-negotiable to have stream processing, like connected devices. So you can think of like connected cars, or you can think of also um, another non-negotiable is situations where you have a lot of changes happening and you need to make a decision for the user in real time. So like Uber and Lyft, when they're like trying to match the right driver to the right to the person to make a better user experience. And like ultimately, if they don't get that if whoever, some people will open Uber and Lyft, request a driver, and whatever comes is faster, they're going to go with. And so that's like, you can measure that experience, and it makes sense to increase the complexity of your infrastructure so that you can give them the best experience and ultimately drive increase in revenue.
Yeah, got it. Well, thank you so much, Xander. It's been great having you on the show. Last question for you. What's the one piece of advice you have for companies that are evaluating stream processing or other real time technologies?
Yeah, I mean, I think coming back to what we were just talking about, it's like a double down on that. Can you increase the revenue, generated by the product, or in some way, or like decrease your costs? So like, can you affect um, um, the company's bottom line with the change? That's basically it, because there is an increase in complexity of the code that you write and the systems you maintain.
Help bridge the gap between data people and non data people. Join us on databeats.community.